Hey everyone, we're going to get started today. We're talking more about slope. So in the last lesson, you watched another video that explained just kind of the basics of slope, but I want to look at what our textbook is saying about slope and kind of put it in some more applied situations. So the first example, hopefully, first of all, I hope you printed out all of these pages. There should be, if you did it just one-sided, 1, 2, 3 from that one document. And then there was also a resource page. So make sure you have all 4 pages printed out. If you weren't able to print them out, it's okay. You're just going to have to take notes in your notebook to write it down, like your answers. And then you'll also want to look at the pages on your computer screen, okay? I did this because I heard from some people that it was a little bit much to look at both the book and like your notebook, so you don't need your textbook for this lesson, okay? So getting started, we're looking at a triathlon. So if you don't know, a triathlon is a race and it has 3 parts, right? Tri means 3. So you start with swimming, then you go to biking, and then you go to running. So we're going to be focusing on the second part of a certain triathlon race, right? The biking part. Because not everyone starts the second part of the race at the same time, right? They have to finish the swimming part before they go on to the biking. They're going to have varying start times. That's what you're going to see on your resource page. So when you're looking at your resource page, there are 4 different participants. And you can see how far they are swimming or biking over a certain amount of time down here. So looking at that resource page, I want you, and you're going to do this right now, to write down and list the bicyclists from slowest to fastest. In this space right here, I want you to write down who is the slowest, second, third, and then fourth, who's the fastest. And then give me a brief little how can you tell. So if you need to pause this video to jot that down and think about it, do that now. Okay, so Lydia wants to describe each bicyclist's rate in kilometers per minute for an article in the school paper. To do this, she sketched triangles like the one for A that's shown on the graph. So this line is the exact same as A on this resource page. You can see the triangle there and the triangle here. Okay, so where did this 4 and 6 come from on Racer's A triangles? So 4 and 6 are just the side lengths of the triangle. All right, at least the ones that we can count. And we can count that it's 4 because we just jump 1, 2, 3, 4. And then the same with 6, 1, 2, 3, 4, 5, 6. Now, what do these numbers represent? Well, the 4, because it's vertical on the y is the distance. So it represents 4 kilometers. And then the 6, which is the horizontal, on the x-axis, which is time, and it's in minutes. So it's 6 minutes. Okay. Now, why is that important? These numbers can be written as a rate in kilometers per minute to describe the distance the bicycle rides as time passes. The fraction 4/6 represents the graph of the line, how the graph of the line goes up 4 units for every 6 units and it moves to the right. That's the slope. That's the slope of line A. I would even go one step further and simplify that because all fractions should be simplified if possible. 4/6 is the same as 2/3. So 2/3 is the slope of A. So what we did is we looked at the triangle that was already there, which is called a slope triangle. We counted how long each of the sides were, and then we wrote that as a fraction and we reduced it. So now we want to see if we can find the slope of the other 3 lines. So we want to find the slope of B. We want to find the slope of C. And we want to find the slope of D. Now, in the resource page, if you go there now, you can see how there are already triangles drawn for you. Okay, there are already slope triangles that are drawn. We already have A's, which is 4/6. If I look at line B, there's this line here, its slope triangle is right here. And that one is, let's see, 1, 2, 3. So you write in a little 3 to show that that vertical length is 3. And then 1, 2, 3, the horizontal length is 3. So that one's pretty easy. To write my slope for line B, it's going to be 3/3, which reduces to 1/1. And that you can just say 1. Okay. Now for C, line C is here. So this is a vertical change of 2, a horizontal change of 3. And it's always going to be the vertical over the horizontal. We sometimes call it rise over run. That's something we say. So the slope of line C is going to be 2/3. And that can't be simplified. That's all there is. Now for D, that one is over here. So we've got a vertical distance of 2, and we've got 1, 2, 3, 4 for our horizontal. So 2/4 can simplify to 1/2. So we have the 4 slopes for the 4 lines. Now go back to what you said up here at the top. When you put them in order from slowest to fastest, did you make the right choice? How can we tell based on our slopes? Well, the bigger your number, the steeper the line, which means the faster that person was traveling. Right before we used to talk about growth and how fast it was growing. The steeper the line, the quicker it's growing. So the bigger the slope, the steeper the line, the faster the person. So if we want to put the slowest, which number was the smallest? Well, the fractions, let's see, is 2/3 bigger or smaller than 1/2? It's bigger. So 1/2 is the smallest. So D is the slowest because 2/3 is the smallest slope. Now, A and C have the same slope. They're traveling at the same rate. Now, it looks different because this person A started before person C, but they're going at the same speed. They're traveling at the same rate. They're going the same number of kilometers for the same number of minutes. It's just that person A got a head start. So obviously person C is never going to catch up to them because they're going at the same speed, and person A has the advantage of getting started first. So even though they're going, like they're not at the same place, they're still going at the same speed. So we can say A and C are the same speed because they have equal slopes. And then we know that B is the fastest because 1 is the greatest slope, right? 1 is the biggest slope, meaning it's the steepest line. Okay. Now, if you're still wondering what is this slope thing that we keep talking about, slope is a ratio. Slope is a ratio, and it describes how steep a line is. we typically say it's like a vertical change over a horizontal change. And you can think of that also as rise over run. Okay, so how do you find slope? Let's write down some steps so we can know for sure every single time what we need to do, if the triangle's not already there. If we're given a line on a graph, how do we find the slope? So step one, you want to look for points on the line, the points where the line goes through what's called lattice points. That's just like where all the grid markers are, because if it's not going through the grid marker, we can't be sure what the point is. So for example, if I were to look at like this point right here on my graph, I can clearly see that it's going through this line, but it's not on one of these. And I don't want to estimate, be like, oh, it's like a half or a quarter or something. I don't want to do that because I'm probably going to be wrong. So we want to try to make sure we pick points that fall where the grid lines overlap, right, where they intersect. And then using those 2 points, you want to create a slope triangle. The direction of your triangle doesn't matter. So like this one is going under the line. You could have also made one going over the line. It would have been the same thing. The next thing you're going to do is you're going to count how long the vertical and the horizontal sides are. So you kind of jump and say, okay, how long is that? Well, that one's 2. How long is that? That one's 3. And then you write the slope as a simplified fraction of rise over run. So you can see here, rise and run. So this one has a slope of 2/3. This one here, 1, 2, 3, 1, 2, 3. This has a slope of 3/3, which is 1/1, or you could just say 1. Now, I did have somebody after the last lesson ask, why do we write it as a fraction? And why don't we do it as a decimal, right? Decimals are easier to compare. Because by writing it as a fraction, we can be sure that we can visually see how high we have to go up versus how far we have to go over to get from one point to the other. It lets us see the growth, right? It lets us see the growth. This is hopefully kind of clicking with something that we did before. So it tells me how I need to go from one point to the next, right? If I did a fraction, it's a little bit, or a decimal, it's a little trickier. Also, the same thing, we don't want to do mixed numbers. We always want to do improper fractions if it's going to be improper. Same reason, we need to see what those triangle side lengths are. Okay. Now, even if you don't make the smallest triangle possible, that's okay, because then you'll just know you need to reduce and simplify your fraction when you're done. All right, let's do a couple of examples. This comes from your book. We want to find the slope of each line by drawing in the slope triangle. Now, these lines are a little bit trickier because the triangles aren't already there and there aren't points already specified for us on the graph. So you need to be very cautious and make sure you pick points that are actually on the lattice points to use to draw your triangle. If you're not sure, pick it. Obviously, you should be using pencil. Pick the points and make your slope triangle. If you think then you have your slope, use that slope to see, all right, well, does that match up for where the point B? If it doesn't, then you didn't pick the right point to begin with. All right, so let's do a couple together. I like to try to go for obvious ones. So there's lots of different points that could have worked here. First one that I see, that point right there. That works for me. I also see a point up here. That could have worked. I also see a point here. There's lots of other points I could have used, but let's just use, I'll just show you a few examples so you can see what I mean by if you didn't pick the right points, it's okay. So if I say I picked this first point and this first point, if I draw in my slope triangle, I count 1, 2, 3, 4, 5, 6 spots there. 1, 2, 3 spots there. Okay, so then 6/3 reduces to 2/3. 2 over 1. Yeah, 2 over 1, sorry. That's why I use pencil. 2 over 1, or if you just want to write 2. So 2, that means that if I had gone up 2 and over 1, that would have led me to another point. Hey, look, it did. Or if I had gone up 2 over 1, hey, look, there's another point. Up 2 over 1, there's another point there. So if I had made a small triangle, it would have been easy to see that it's 2 over 1. But it really doesn't matter where on the line you make the triangle or how big or small, as long as you pick points that are actually on the line and on the lattice points. All right, let's do the one next to it. Let's find some points. So let's say, here's one right there. That works. And you have to draw this in, right? At this point in your life, I need you to draw in the points and make your slope triangle. And then I see another one here. At least I think that's right. Let's try. So if I draw, so I'm going over and up. I'm making a nice, cute little right triangle here. This is 1, 2, 3, and this is 2. So my slope is 3 over 2. That doesn't simplify. Now let's make sure I did this correctly. If I did it right, then if I go up from this point another 1, 2, 3, and over 1, 2, it's going to land me back on the line. Yes, I did it right. Good job. Me. If you're getting this, if you want to pause and try 3 and 4 on your own and then check back to see if you got them right, go ahead and do that. Otherwise, you can follow along with me. Let's pick some points. I see one here, and it clearly goes through the origin, so might as well use that one. Draw in my triangle. This is 2. This is 3, so this one has a slope of 2/3, which is different than 3/2, right? You can see 3/2 is obviously bigger than 2/3, and this line is steeper than that line there. This one is the steepest of the 3 that we've done so far, because 2 is the biggest of all those numbers. Now, if I look at the last one, I have a point here at the y-intercept of 4. And then, let's see, I see a point here. I draw in my slope triangle. Count 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4/6, that can simplify to 2/3. Hey, that's the same as that one. They'll look a little bit different as far as the lines are concerned because you can see how they have different y-intercepts, right? This one goes through the origin, this one goes through 4, but they have the same growth rate, right? They have the same slope, the same steepness of the line. All right, I hope that cleared it up for you a little bit if you were confused over the last one. I think everybody was good last time, but never hurts to do more. What you're going to do today, there are 3 lines here. Made them nice and big so you can see them. You're going to need to find the slope of each of these ones. Then you're going to turn in your assignment on a Google form. All right, so just 3 short ones to answer. Please write it as a simplified fraction when you type it. All right, if you have questions, email me. Talk to you guys soon.